For previous class, we look at expansivity of liquid, area, and cubic expansivity. In today's class, we're going to talk about liquid expansivity. Now, what is liquid expansivity? You know that expansivity is the rate at which a substance or a material increases when there's a what? Increase in temperature. Now, when you talk about liquid expansivity, you can't just carry water and put in, or carry a red oil or not oil or anything that is liquid form, and just come and pour it on or a fire. I getting for it to increase. No, you must put it in a what? A vessel or a container. Now, for instance, now what is going on when you put it in a container? Let's say this here is a gallon. Hope my drawing, pardon me for this drawing, no. So this is a gallon. Now, let's say there's a liquid on this gallon. Now, what happens if you increase the temperature in this gallon? Let's say it was 0 degrees Celsius. Alright. Now, if you increase the temperature, maybe you put it on a Bunsen burner and increase it with heat. What happens? This liquid can be an oil. This liquid can be anything. You get? Now, this liquid is going to increase in volume. If it was here before, it might change to be here. Now, the liquid is going to increase. However, when you mean liquid expansivity, it's not only the liquid that is going to expand. This vessel or container that you put it into will also expand. Are you getting me? So, for example, if this was a rubber, it's also going to expand. Whatever it is also going to what? Expand based on the what? Increase in what? Temperature. Because even ion also expand. That's when you have linear what? Expansivity. So whatever the vessel may be, it's also going to expand when you what? Increase the what? Heat or the temperature. Now, what will now be the formula? Since this container is also going to expand, now the liquid expand, or the rate at which this liquid is going to expand, is what we call apparent liquid expansivity. Apparent expansivity of the what? Liquid. The rate with which the liquid expand from here or increase from here to this place, called apparent liquid expansivity, or apparent expansivity of the liquid. Why the expansivity, the rate at which this container is going to expand, is what is known as expansivity of the liquid. Sorry, cubic expansivity of the vessel, represented as this form. Cubic expansivity of the what? The vessel. Cubic expansivity of the what? The vessel. Now, I'm trying to get the whole expansivity, because we want to know what happens. If you want to add, if you want to know the total expansivity of this liquid, you also add the liquid that expanded when, if this vessel expanded to this form here, liquid has also entered here. I get a liquid have occupied there. Now, to get the total expansivity of this liquid, or the liquid expansivity of in this vessel, you must add the expansivity of the liquid, the apparent expansivity of the liquid, plus the cubic expansivity of the vessel. I getting? Now, that is now going to be called real expansivity of liquid, represented by this form. Hence, real expansivity of liquid is equals to apparent expansivity of liquid plus cubic expansivity of what? The vessel. So the vessel also expands, and some water or some liquid enters that expansion point, and then that is why it is very small. Assuming the vessel does not expand, you see it's going to increase here, but some liquid have filled in that space that it expand. This is now becoming what? The formula. However, in solving questions, you should know that the apparent cubic expansivity is equals to the mass of the liquid expelled, mass of liquid expelled over remaining mass times temperature change. Or increase in what? Temperature. Now, what do we mean here? What we mean here is that the mass of liquid expelled There's no how that you're going to increase the temperature maybe from 0 degrees Celsius to 50 degrees Celsius and the liquid will still remain. Some liquid is going to what? Expelled, and that liquid has mass. And also the temperature it's going to change from 0 degrees Celsius to 50 degrees Celsius is also going to be recognized. Now, in order to get the apparent expansivity, is the mass of liquid expelled over the remaining mass times the temperature was changed. Now, also remember that cubic expansivity from our previous video is given by 3 times alpha, which is what? Linear expansivity. So once you are given, you're talking about this formula, how a liquid expand, the vessel expand, and instead of them giving you the cubic expansivity, they now gave you the linear expansivity. You can use the linear expansivity times 3 to get the cubic expansivity. Now with this, we are done already. Let's look at question based on this. Let's look at this example question. It says a density of glass bottle contain 44.25 gram of a liquid. So the mass of that liquid is 44.25 gram at 0.0 degrees Celsius and 42.02 gram so the at 50 degrees Celsius. Now the mass decreases from 44.25 gram to 42.02 gram when it what increase in temperature by 50 degrees Celsius. So calculate the new cubic expansivity of the liquid. They now give you linear expansivity. Now this is simple. From what we have solved so far, we remember that new cubic expansivity is equals to apparent cubic expansivity of the liquid plus cubic expansivity of the vessel. Are you getting me? Cubic expansivity of the vessel. However, if you look at this question, you don't even have your apparent cubic expansivity, you don't even have your cubic what expansivity. But then remember that your apparent cubic expansivity could be getting by when you use the mass expelled over remaining mass times temperature what? Temperature change. I get him. Mass expelled. Now, what is the mass expelled? If you look at this, the mass changes from 44.25 to 42.02, which means that mass has been expelled to remain this. I get it. This is the remaining what? Mass. Now, the mass expelled is going to be YA equals to mass expelled. When you use this and minus this. Now, let's do it. 44.25 minus 42.02. All right, this remove this. You have two points. You now have 2 3. So this is the mass expelled, 2.23 all over remaining mass. What is the remaining mass? So this was the initial mass and this expelled. Now this is what is remaining. So this is the remaining mass, which is what? 42.02 times temperature change, which is what? 50. All right, now when you work this, what are you going to get? When you work this, you're going to get 1.06 times 10 raised to the power negative 3. All right, that's what you're going to get when you work this. Now that is your what? Apparent cubic expansivity. What about the cubic expansivity? If you recall, they gave you linear expansivity, which is what? Alpha. If you recall, cubic expansivity is equals to 3 alpha. So now to be able to get this um um our cubic expansivity, we can times the linear expansivity, which is alpha, by what? 3, which is now going to be equal to 3 times 1.0 times 10 raised to the power negative 5 is going to give us what? 3 times is going to give us 3.0 times 10 raised to the power negative what? 5. That is what? The cubic expansivity. Now our parameter is complete. We now need to find the new cubic expansivity of the what? The liquid. Now in doing that, I will now say that new cubic expansivity is equals to what is YA? That is apparent cubic expansivity of the liquid, which is 1.06 times 10 to the power negative what? 3 plus this other one, which is what? Cubic expansivity of the vessel, 3.0 times 10 to the power negative 5. Now when you plug this together, what are you going to have? What are you going to have? What are you going to have? This plus this is going to give us 3.0, I think 9 or something, times 10 raised to the power. Now, since they're adding, this is going to give us minus 3 per Kelvin. I get it. So this is our answer for this question. Now, what are the other things you need to know? What are the other things you need to know? I'm going to stop here. If you want to join my physics online class, complete physics, if you don't understand physics from A to Z, I want to tutor you. And if you know someone that don't understand writing JAMB, GCE, or WAEC, or in 200 to 100 level, WhatsApp me on 081 539 57022 for the tutorial. You can see the number on the screen. If you're in another country, consider adding plus 234. All right. See you on my next video.